Hey guys.
Hey guys.
Today we're taking a trip to the Galarzen residence to talk about some stuff about temperature,
Specific heat capacity and heat.
and specific heat capacity.
I said that already.
You're supposed to do heat first.
God. Okay. All right. And off to our first topic, temperature. It's good.
When he was 10, his father left him and his wife bedridden, and his mom went quick, but Alex got okay.
Okay, that's hot. So be careful. Okay, first one.
You can see the smoke rising from the ashes.
Scoot over.
It's been recording this whole time.
Hey, Kenneth, define temperature for us, please.
Temperature is a number that corresponds to the warmth or coldness of an object. It is measured by a thermometer. It is a per particle property. There is no upper limit. There is a definite limit on the lower end.
Interesting. Well, yeah. So, Kenneth, tell me more about temperature.
Temperature is proportional to the average translational kinetic energy per particle in a substance. For gases, it's how fast the gas particles are bouncing to and fro.
So, you can't
For
really
liquids,
see
it's how fast particles slide
Jesus.
against one another.
Okay. You have any more to say?
And lastly, for solids, how fast particles move as they vibrate and jiggle in place.
Well, you heard it here now, folks. Three different bowls consisting of water at different temperatures. Why don't you? So right here, can't really tell, but we have hot water right here that I just heated in a pot. This is room temperature and this is cold. So Kenneth, why don't you put your hand in the cold,
Oh, did you mean the
Yes.
bowl? Oh, okay, sorry. Let me wipe my hand on my brand new H&M jeans. Okay, so here's my hand, and I'm dipping it into the cold, icy water. It's right here in this bowl filled with ice, right here. Okay, you ready? Ready for this? Okay, here we go. Okay, ready? Okay. It's cold. It's very cold.
All right. No, it's cold, obviously.
It's very cold.
Now take it out.
Take like an ice
Alright.
cube?
Just hold.
Oh, my hand. Oh, take my hand out.
Yes.
Okay, sorry.
All right. Now put your other hand maybe in the hot water, or put a finger or two because it's hot.
If I get scalding hot heat water, I'm gonna die. It's hot. Okay. You're like, okay.
Dip.
That's really hot.
All right. So obviously they're different.
Just hurry up with the instructions and tell me what to do.
They're obviously different temperatures, right? All right.
Obviously.
Put your.
What do I do?
Put your hot hand in the cold water.
Not the middle one?
No.
I thought the experiment was in the middle one.
No.
Okay. Do I put this in the hot one?
Yes. See, doesn't feel as bad, right?
It feels less bad.
Yes,
not
less bad.
as bad. It's hot. It's really hot.
Did you just say?
I feel like my hands are confused now as to what temperature that they are at. I think you broke some of my temperature-seeking nerve endings, and I will sue you for the medical damages to my body. Don't joke about this, Skylar. This is a very serious topic. Medical expenses are very expensive these days. Don't make funny faces.
So now we're going to talk about heat. Can you put a text there?
Yes.
All right. So heat is defined as the internal energy transferred from one thing to another due to a temperature difference. So
Anywhere but here!
As an example for this, we're going to take one of our ice cubes here. Take one of our ice cubes here. See, it's obviously cold. And this is our hot water that Kenneth just scalded his burning hand into. So now, we're going to put this in the hot water. And as you can see, the ice cube, it'll slowly start to melt because the heat, thermal energy transferring from the hot water will transfer into the ice cube because the high temperature will transfer its energy to it, so that you can see.
Wow, Skylar, that's really cool.
You should do like a friggin' time lapse. Watch it melt. What? There's no ice cube left. Wow. You know what, Kenneth? Internal energy never flows unassisted from a low temperature to high temperature substance. So, that little ice cube, while it was there, being very cold, it didn't really flow from, because its temperature was so low, it didn't transfer to the high temperature as well as it did with the high temperature to the low, so.
The high temperature water transferred its energy over to the ice cube, thereby increasing the heat energy in the ice cube and therefore melting the ice cube.
I already said that.
Yeah, we didn't understand you, so well, that's why I had to re-say it.
Really now?
Pretty sure.
Alright. Kenneth, why don't you define specific heat capacity for us? Because I don't really want to do it, so.
Sure. It's not like I'm editing the video, recording the video, and editing all of this.
It's not like we're filming at my house, using my resources.
Anyway, being the person who's actually doing the work, specific heat capacity is defined as the quantity of heat required to change the temperature of a unit of mass. Specific heat capacity is defined as the quantity of heat required to change the temperature of a unit mass of the substance by 1 degree Celsius. Like thermal inertia, resistance of a substance to a change in its temperature.
Great.
Wait.
What?
Like thermal inertia, resistance of a substance to a change in temperature. What does that mean? Well, it's not like you would know. You never pay attention in class anyway. So.
Okay, ready? And action. Well, I guess I'll talk now. So, different substances have different thermal capacities for storing energy. For example, these are two different pots. So, let's say like this is an iron pot, or this is an iron pot, or whatever. For an iron pot, it takes about 2 minutes to raise the temperature of an iron pot of water to boiling temperature. Kenneth, why don't you hold up the other pot?
Oh yeah, that would be a fun thing to do. Here's the other pot.
Well, it takes less.
$4.99 at Kohl's.
It takes less than 1 minute to raise the temperature of the same quantity of water in a silver pot to boiling temperature. So, because of the different substances, they have different specific heat capacity. So it takes longer or shorter for them to store and take in heat. And You know what?
I don't know.
What?
Well, guys, I hope you had fun learning with us about temperature, heat, and specific heat capacity. Thanks for watching.
You sound like you're having a great time.
I am having a great time.
Are you? So you sound like you're very insulting right now.
Oh, I am not insulting anyone right now.
You're being really sarcastic.
No, I'm not.
No, you definitely are.
Like, you understand how people work.
Like, you know how to dress. You everyone hyped you up about your new freaking outfit with your new shoes and your skinny jean pants that hug your butt too tight. I don't like it.
You take that back.
Yeah, right.
You
never
apologize.
take it back. I will never apologize.
You apologize right now, or I will take your hydro flask and throw it over that fence.
Do it, you won't.
No, my hand, just get closer. Like your hand is about to grab it, but I swiped it already, so it's like...
Like